All right, so I'm Sean Feldman. I'm from Calgary in Canada, which is in a province called Alberta. I started attending this meetup, these user group sessions, just because it's quite nicely aligned with my lunch break. So around noon. It was kind of interesting and led to this talk as well. So we're going to talk about Azure Service deep dive, where I will try to bring as much interesting information about the service itself and how to use it, and not just the code snippets, which you will see plenty. So about me, I'm a consulting solution architect, mostly in .NET space, Azure specifically. I'm a past contributor and still to this day do a little bit of work on the open source project Service Bus Explorer tool, if you've used that. If you haven't, I'll mention that later in the talk. I've also worked on Service Bus for Azure, various transports, Azure Storage Queues, Azure Service Bus Transport, hosting options, persistence, and the latest function support to run Azure Service Bus and Azure Storage Queues abstraction on top of functions. So that's me in a nutshell. Before we start talking about Azure Service Bus, there's a little bit of gamification. No, I'm not asking you to identify all the Azure services. These are all, well, not all, but most of the compute services in Azure. And the question is, what's common between all of those services? And don't worry, school is over. I'm not expecting an answer. What's common is that they all can benefit from messaging, because sooner or later, when a solution is growing and expanding, scaling out, if you wish, the necessity to start using messaging is becoming greater and greater. And I believe one of the previous talks, it was mentioned that queuing is helping a lot. So let's start with Azure Service Bus. Before I go into details of Azure Service Bus, I have to acknowledge the fact that Azure Service Bus is not the only messaging service, right? In Azure specifically, there are quite a few. So if we go over them, Event Grid, Event Hubs, Storage Queues, and Service Bus, I give them subtitles to kind of describe better what they are. I do divide them into two distinct groups. The first group is event-specific messaging, and the other one is more general messaging, right? So the distinguishing factor might seem not necessarily that important, but I do use message as a generic term, which can imply events, can imply commands, right? When a message is not just a payload. And within the messaging, there are storage queues and service bus, but as the titles indicate, storage queues are more for simple tasks, where service bus is more designated as enterprise messaging. And when I say enterprise messaging, that's basically features behind the service that we can utilize without implementing those features ourselves. And ironically, commonly those features are implemented by compute, which we don't have to get involved with, right? So that's the idea. So we're going to focus on Service Bus. I'm going to go to the portal. The first thing that you can see is tiers, right? There's, okay, you want to provision Service Bus? No problem. Would you like to have basic, standard, which is the consumption tier, or the premium, which is the provision tier? And it's kind of ironic because that's the very first confusing point, but not the last confusing point about this enormous service called Service Bus. What are these tiers? Well, we know that, for example, if you go with Azure Functions, there's a consumption tier, there's premium or provision. And basically the SLA that you get and potentially some of the features and whatnot, same thing applies to Azure Service Bus. But what's really confusing is the basic and standard. Like, why would I really need two consumption tier? And the truth is, we don't really need basic. It's no different from standard, other than we don't have, we only have queues, right? But if you're using standard or basic, you're paying the same thing for either of them, you just go with the standard. That's pretty much it. There are some other limitations to basic. If you ask me, basic should go, and I believe it will go. It probably will be replaced by something that will go in the middle between standard and premium, but we'll see what future holds for us. Now, standard and premium, the first shocker that people get is when they play with the drop-down option in the portal or look at the documentation, is that it's like $10 versus $670 or whatever it is in translation to British pounds. Yes, it's true. And the vast difference is there for a reason. I'm not justifying Microsoft pricing strategy. But standard is also confusing because a lot of times people think, wait a second, every time I provision a standard namespace, which is necessary in order to create views and start sending and receiving messages, I'm going to pay $10. So if I have a team of 20 developers, that means 10 times 20. That's not true. What you pay is a flat fee for the service, regardless of the number of the namespaces provisioned within the standard tier, as long as it's on the same subscription. So if you have a team of 20, it's a it's a flat fee of $10 per month for the namespace. Then whatever the consumption, whatever number of operations and messages that you send on whatever the number of the namespaces that are provisioned. So no longer sharing namespaces between developers on the same team, prefixing or suffixing views, none of that, right? Purely isolated in the menu. Now, premium, we're going to talk about premium later. This entire talk is going to basically talk about features that are available on both consumption and premium or provisioned tiers. Now, it's kind of interesting because over the time, Service Bus has evolved, especially the broker side. And Microsoft has done a fantastic job of hiding the differences between the two, because even architecturally and implementation behind the scenes is not quite the same, even though they behave the same. And that's really, I'm applauding to the engineering and execution of the Service Bus team, because it really makes it feel like it's exactly the same product, just different offers and features turned on and off. All right, so with that, how are we going to learn about the service? There's two parts to the service: the broker side or the server side and the client. Now, the clients can be either in any language. Usually language is associated with an SDK, .NET, Java, Python, etc., etc. And by now, probably there might be even more. I'm not tracking all of them. My focus is with .NET, so the talk is based on .NET. But most likely, if there is a popular SDK language, there is an SDK for it supported by Microsoft. And in order to get going, obviously, like everything else these days with .NET or probably any other platform, we started with packages, right, in order to utilize the service. With Azure Service Bus, there's a little bit of history, but the package you're looking for is Azure Messaging Service Bus, right? This is the published package for Azure SDK. And the reason why I'm bringing this up to your attention is because this is what is called Track 2, or actually third generation of Azure Service Bus SDK for .NET. There were two other ones. There was Windows Azure Service Bus, which was .NET framework only. So if you are working on a project with a client that has to go undergo a migration, you are likely to see that one, or its successor, Microsoft Azure Service Bus, which was the first .NET standard SDK for Azure Service Bus. So these two are by now kind of obsoleted, and they should be using the Azure Messaging Service Bus. Obviously, it's cross-platform, so love is in the air. You can use it anywhere you want. Now, if you're looking specifically for issue tracker or the source code for the client, this is the repo. If you're looking for the source code for the broker, there is no source code available. Obviously, that's the secret sauce. But there is an Azure-Service-Bus repo on GitHub, which is used as an issue tracker for the broker side problems. So if there's a feature request or a problem with the feature, you can go there and raise an issue. All right. Azure Service Bus is using MQP 1.0. That's the protocol. Now, some of you might have used in the past, or even now, RabbitMQ. It's also AMQP, but it's AMQP 0.9 standard, right? Or 9.2, I think. Not quite the same. Implementation is slightly different. Saying that, there is a possibility to bridge between RabbitMQ and Azure Service Bus. There's a plugin, I believe it's called Shovel or something like that. So it's an option. Also, I should mention that Azure Service Bus fully supports JMS 2.0. So if you're in the Java space and you want to replace your broker with Azure Service Bus for whatever the reason, it's possible. All right, that part is done. I want to send and receive messages. The basic way to do that, obviously, is by using a queue. Now, Azure Service Bus has a logical name for queues. They're called entities because queues are not the only things that you can leverage. And for now, I'll just refer to the queues, but remember entity and queue, interchangeable name. So how do I manage the queues? Basically, CRUD operations. There's two ways. One is like any other SDK, any other service that allows you to perform CRUD operations on the resources. You have a management library. You can use that. Unfortunately, you have to go through Azure Active Directory, and it's a little bit of code, and it's an additional package to take dependency on just to create your queue, right? You can pre-provision the queues, which is a smart way of doing things, and you don't necessarily want to do it at runtime. But if you do need to do that at runtime or perform checks or whatever, you can also do it using the client itself, Azure Messaging Service Bus. It exposes a Service Bus administrative client, and using the client, you can pretty much do everything that you need to provision your queues and your namespace topology or infrastructure. So in this specific snippet, what I'm doing is I'm using the client to check if the queue exists. If it does, delete it and then recreate it. Obviously, this is great for them. This is not good for production code because by deleting the queue, you're going to be eliminating all of the messages that were sitting in the queue, right? Defeating the purpose of messaging to begin with. So take carefully reference to the samples that I'm giving here. Not everything that you see is great and should be used as is. I do have to acknowledge the fact that the new SDKs are fantastic, not just for Azure Service Bus, because they enforce async await. Just because these are IO bound operations, you're constantly talking to a remote server, to the broker, and to the service, right? It's all the same thing. And these operations should take advantage of the async APIs. All right, so with this, we can provision a queue, right? Which means that we need to connect. Connection, in this sample, I'm using connection string because it's the simplest way, even those passwordless, I think that's the concept these days, is an option. And you can create service bus administrative client using one of the following options. So you can connect with managed identity, Active Directory, right? Connection string, whatnot, whatever makes sense for you in your scenario. All right, with that out of the way, we can start focusing on actually working with Azure Service Bus. And the first thing we're going to do is sending a message, right? So sending a message means that I'm constructing a message and pushing that on a queue, handing it off to the broker, and everything that entails with that. The code itself is fairly straightforward, right? My package is referenced, NuGet package is referenced, and the code is the following. Service Bus client, just because we need to establish the connection to the broker. I'm going to talk about establishing connection, what that means, and creation of the senders and receivers, specific clients. We're going to chat about that a little bit. The Service Bus message is the construct that we have to utilize in order to pass messages around. Well, send messages, because receiving is slightly different, and we'll talk about the difference. The payload that you pass in is whatever commonly known as the body of the message, right? Or payload. In this case, it's just the string for me. When we send a message, along with the message, unlike, for example, Azure Storage Queues, who's familiar with Azure Storage Queues, Azure Storage Queues only has the body. Azure Service Bus also has metadata. And that metadata, which is packaged along with the message, has two categories. One is the system properties, and another one is user properties or application property, right? So system properties, for example, subject, right? It's a designated field to provide some hint about the message, for example. In the past, it was also known as label. So if you're using older tools that haven't changed the naming, you will see the label. There's also message ID, for example, which you can specify yourself. If you don't, it's auto-assigned a GUID or something. There is a content type, right? A designated field or property, which is for client usage, client code usage, to indicate what's the content type of your payload if you do that. Now, message application properties is basically arbitrary property bag, which you can utilize. That is it to the message itself. So in my case, coming up with just random machine as a key, right? That's my key for the header, and whatever the value of the machine, we'll see that later. Once the message is ready, we just ship it, we send it. Dispatching is done by sender, service bus sender, and we send the message. That's it. The moment we're done with the sending, we can close that client or the sender, but we need to remember that closing a client is disposing the client. It's not, sorry, in this sender, the naming is not the best here in this example. We're closing the sender, we're not closing the service bus client itself. And we'll talk about why this is important a little bit later. So this is great. I can construct the message, I can send the message, but there's something to keep in mind. First of all, any service has a constraint on the payload, that size of the payload that can be shipped or dispatched. With Azure Service Bus, this is where the tiers, consumption versus premium, are kicking in. On standard tier, the maximum message size is 256K, where on the premium tier, it's 100 megabytes. Now, that's quite a screaming gap, right? From 256K to 100 megabytes. Now, 100 megabytes, I would say that's a very edge case. You really shouldn't be sending that big of a message because that will basically have impact on your performance. Certain applications, for example, if you have X-rays that need to be attached to the message, and that attachment is required upon receival of the message for successful processing, then it makes sense. But otherwise, strive to have smaller messages. The other thing that is important to remember is that the payload is not the only contributor to the message size. All the properties, system properties, and application properties contribute to the overall size of the message as well. And because this is AMQP, the data is encoded and transferred, so that means there will be an additional slight overhead contributed by AMQP as well. So when you send a message on a standard tier, for example, and let's say you have 255 kilobytes of data passed to the payload, and the message is failing, it's not sent out, because whenever the message is too big, you will get an exception. You might want to look at the application properties or slightly reducing the payload, right? And if you can't, that means you have to either use the premium or use some sort of plain check pattern, which is possible with Azure Service Bus as well, as a testing code. All right, so with this in place, we sent the message. If we run the code, we would like to go to the queue. I'm going to use Service Bus Explorer as my tool, right? And we're going to look at the queues. Here's our queue, and there's the message, right? The message should contain the payload, right? The label that we've assigned deep dive. And on the right side, you will notice the custom property or application property called machine. The key is machine, and the value is beast. Full disclaimer, a few years ago, this was a beast, not anymore. So with that, we've successfully sent our first message, and now we would like to receive that message, right? The opposite thing. Very similar code, except there are new concepts and pretty much be ready for new concepts every topic with every topic. There's two receiving modes. There's receive and delete, and there's peak log. And what's the difference between those two? Because it's quite important to understand. Receive and delete means the moment broker has communicated a message, has given the message to the client, the message is gone from the broker. It's deleted, which means this is at most once delivered, where peak lock is at least once delivered. What peak lock is doing, it's not giving the message to the client, it's leasing the message to the client for a certain period of time. And that time is limited, by the way. The client has to do something, or it's called settle the message within that lease time. You can complete the message and indicate to the broker, to the service, that the message is completed. Only then it's getting removed from the broker. You can trash the message, throw it into the garbage bin. We'll discuss that later. Basically saying that, no, can't do anything with the message, don't care. You can postpone the message in several ways. We'll look at those as well, right? But you have to indicate to the broker what's the action to take on that message. If you don't do that, or the lease time is expiring, the message is just becoming available to any other competing consumer, right? Which can cause some interesting side effects. All right, so, and I should mention that by default, peak lock is the mode because it's the safest mode, right? If you want to override it, you have to specify that explicitly. Now, in order to receive, again, there's multiple ways. Everyone likes choice, right? So we can choose. There is a simpler scenario to use service bus processor. What is that? That is basically a message pump created by the SDK developers for us to implement an easy way of receiving and processing messages. So from the service bus client, which establishes the connection to the broker, we provide the queue, well, not quite destination, more like a source, but forgive my naming. We create a processor, and very .NET specific API in this case, we have process messenger async and process error async, two events where you can subscribe and have your callbacks. When either one of these is executed, you get all the information necessary as a event argument. So for example, for process message, we're going to get the message and we're going to get the ability to settle the message in any way we want if we need to. When a message is failing, when there's an intermittent exception taking place, we're going to get that error so that, for example, we can log it or we can report it or trigger something, whatever it is, circuit breaker for maybe, and continue because retries will take place. And we'll talk about retries as well. Now, a more advanced scenario, which doesn't look like advanced scenario compared to the processor, is actually handling receiving of the messages manually, right? Literally creating a receiver of the service bus client and receiving the message, a single message or several messages. We'll talk about the differences in a bit, but you basically then need to create your own loop. If you want continuously receiving messages, you have to create your own message pump, which service bus processor is giving you out of the box. Now, I kind of lied saying that the processor is simple scenario because it's not that simple if you look at what really takes to use it. First of all, there is out of the box, the configuration is fine for, very simple scenarios. But most often I find that you need to configure or provide the configuration for service bus processor, right? And this is this first chunk here. I'll go into details in a bit. When you create the processor, you subscribe to the events, writing the callbacks, and then you have to start processing, invoke start processing, and optionally you can also stop. So the way processor works is you can literally pause and continue. So if you have something like a Windows service, for example, right, which can be paused and continued, it's the same idea. In general, messaging processing, you usually have a stream of those messages coming in, and as long as your process is live, you're receiving messages. Unless you're in an environment like Azure Functions, where you don't really need to do any message pumping because messages are given to you, right? Your function is invoked when a message is available. This whole aspect is abstracted with functions or lambdas. So the options. These options are interesting because they are not there just for the client's sake. They actually provide a lot of information about the server side as well. So for example, autocomplete messages. Here in this case, I set it to false. That's the receive and delete, right? The default mode. Because what happens is, by default, the processor is giving us a message when one is available. And upon completion, successful completion of the callback, it will automatically complete the message. Sometimes we want to control that setting, right? We want to control what we do with the message that we are processing. So we can override the auto completion. And then in the handler or in the callback, we can do it ourselves, right? We can complete, we can trash it, we can postpone it, whatever. Mass concurrent polls is number of these callbacks, processing callbacks that are taking place at any point in time. So for example, if I want to be able to process up to 100 messages per second, I would need to dial up mass concurrency calls to 100, right? Which means that I'm literally processing concurrently per second up to 100 messages, right? But we need to be careful with that setting. In this case, I set it to 1 because in most of the demos, we want to see chronological order of the messages to make sense out of it because our brain is not asynchronous. Well, I would argue that some people are, not most of us. And it's really easy to set mass concurrency calls to see one message at a time, especially when you're debugging, right? Things like that. Now, we need to be careful with the concurrency because there's another setting that is called prefetch count. And prefetch count is kind of interesting fella because what it does, literally, it's prefetching messages. So going back and forth between server and the client to request a single message is kind of expensive, right? What you want to do is you want to prefetch as many messages as possible in order to save the round trips. But then what is interesting is that there's that pesky please duration, or it's called log duration. Let's say it can be somewhere between a few seconds, which makes very little sense, and up to 5 minutes nowadays, at least today. So you have a lease up to 5 minutes, which means that this process message async fallback can only execute up to 5 minutes. What that means in regards to the messages that were prefetched. Think about it for a second. Because the moment messages leaving the server, not physically, but the reference to the message, the clock starts ticking. The lease is kicked off as well. So if it takes me a very long time to process a single message, even if I scaled up and my prefetch is too greedy, what will happen is the prefetch messages will be sitting there in a buffer on the client side. Their lease timer is running out. And by the time those messages from prefetch move into the callback for processing, my lease might be broken. So when I'm done processing those messages and going to complete them, or they auto-complete it on my behalf, we're going to get an exception because the broker will say, sorry, you don't own the message. You don't hold the lease anymore. And these are the scenarios when you see those pesky concurrency issues when the message is processed more than once, right? Like someone says, well, look, but my handler or my callback is running only 30 seconds or less than a minute. And somehow I get double, triple processing. Well, that's most likely because our concurrency is either not big enough or we are prefetching too much, which is also possible. Another option is that our log duration or that lease time is too low for what we have, right? Because I think by default it's like 1 minute. So that's one of the examples. Now, if there's an exception during processing, we're going to get notified, and we're going to see that in a second with the demo. So, we sent the message. I'm going to use the processor. Here we go. Received message. Nothing extraordinary. But when exceptions are happening, that commented out exception that we saw, we're going to see all the retries kicking in. right? So in this case, there were 3 or 5 retries, and you can see that all the information is available. The entity path, which we were receiving from, the queue that we were receiving from, the namespace, because guess what? If your application is working with more than a single namespace, there's a chance that there's a similar entity or queue name appears on both. So you want to know from which namespace, with what namespace there was a problem. Error source is our callback, right? And the exception itself. All right, so something really interesting, again, not client side, but the server side. If we're using manual receiving, using service bus receiver, and we say receive messages async, that's a blocking operation, right? It will literally block until we get the message. Now we could set a timeout and passing a time span indicating that, hey, within this period of time, if I don't get a message, just get back to me, which means we'll get null. And we need to check whether there is a message or there was no message. We can also receive manually multiple messages, right? So in this case, I can say, hey, give me five messages, or give me 5 messages within this period of time. Now here's the question. I'm asking the broker to provide 5 messages. How many messages are we going to get? And there you probably think, Sean, what kind of question is that? You ask for 5 messages, you're going to get 5 messages. Not true. What we're asking for is up to how many messages to get, the maximum number of messages. This is not the exact number of messages that you're going to get back. What you will get back is whatever the server is capable immediately returning back. It does not mean it's going to be 5, even if the queue contains 10, 20 or more messages. So that's a very interesting behavior of the Azure Service Bus, right? If you need to get a specific number of messages, which I usually discourage from because you don't want to do that type of development when you know exactly the chunk of the messages you're going to get. But if you need to, you will need to do most likely 1 or more manual receives to accumulate those messages, which is problematic on its own, but that's a different story. All right, so this is great. We were able to send a message, we're able to receive a message, and I mentioned something about connectivity that we probably should sort out from the beginning to understand sort of the implications of Azure Service Bus that can have on your system that you're building, and that's the connection management. Connections are important because, like the SQL Server database, for example, you have a connection, and there is also connection pooling that is taking place because connections are not cheap. You're literally establishing a connection to the broker that is kept throughout the application, because destroying those connections is very expensive. The other thing is there is a limited number of connections based on the namespace tier, standard or premium. There's a certain limit, and if you have, for example, competing consumers that scaled out and whatnot, you need to be aware of those connections. The way I usually describe it is connection is a channel, and every sender and any receiver is using that channel, right? It's like water pipe, and you can pretty much utilize all of it, or you might not utilize all of it, but you have to remember that it's just a single pipe. A connection is a single pipe, and the connection pooling is utilizing the same connection, the same pipe for everything that you do. If you need more than a single connection, then you actually have to be explicit about it. So going back to the code, the Service Bus client is providing for us the connection pooling. It establishes the connection, and it serves as that pipe to the broker, to the server. Whenever we create senders or receivers or processors of the same Service Bus client, we use the same, which means we have a single connection. Now, if we want to have more than one connection, obviously we create more clients, right? But again, remember, every coin has 2 sides. So the downside of this is that we utilizing more connections. It is more expensive in terms of bootstrapping those connections, especially if you do it dynamically and whatnot, and not always you necessarily need it. But for the sake of the demo and describing how the interaction with the broker works, let's use these 2 snippets to run through. And we're going to look at the TCP port because By default, Azure Service Bus is connecting via TCP. You can also do WebSockets if TCP ports are blocked, but preferably going through TCP because that's the needed and the most standard way. So the first snippet, if you remember, we had a single service bus client, which generated, we created receiver and sender on that one. And the second snippet, we created two clients, and sender was from the one and the receiver was from the second. So this is the first snippet. You can see we established connection to the port 5671, the TCP port used by Azure Service Bus. And the second snippet, where receiver sender use different clients, we had two connections established, literally, so two pipes. Port 5671 is the standard port. If you find yourself with a client that cannot establish connection, most likely their their firewall is blocking the port. Most likely, WebSockets is the solution, unless you have the time to go back and forth with the IT to unblock the port. Anyways, so this is great. Now, there's a concept of, is there a question? No. There's a concept of recoverability because, again, we're talking to a remote broker, and failures will happen. The concept of retries is baked into the client itself. Some basic retries. And just to show you the example, the retries are standardized on the level of the service bus client and propagated into receivers and senders or a processor. Could be overridden if you want. And usually it handles all the intermittent problems. So you can use either fixed mode or exponential mode, whatever you want. Maximum number of retries, timeout, and whatnot. You can even create your own retry policy, right? If it needs to be something funky. It's basically out there. The one thing that I will mention is the retries baked into the client itself are usually quite good. And when you build the solutions on top of Azure Service Bus, account for the fact that problems will take place in terms of connectivity and whatnot, right? And it's okay for exceptions to take place. One of the awesome values of messaging is that it's designed to tolerate failures, which means messages will be retried. But keep in mind that retries is not everything. For example, every message has, on the broker side, every queue, not message, has a concept of delivery count, or how many times a message can be delivered to a client before that message is, thrown into a garbage bin. The reason for that is because the service does not want to get stuck on a single message that is, for example, poisonous message, or there is a bug in our code that triggers a condition of continuous failure. So as a protection mechanism, there is a max delivery count property on every queue in Azure Service Bus. And the message, when you receive it, has that delivery count as a property, as a system property on the message, so that you would know, if you need to, how many attempts have been exhausted, or if you need to create some custom logic, whatever. So it's not just the retries; it's also something on the max delivery count on the queues. All right, so now we're done with the basic stuff for Azure Service Bus, and we can start to look at more advanced features or messaging as opposed to simple queuing. The first one is scheduling, and word of caution: do not treat Azure Service Bus as a storage. And what I mean by that, not necessarily the size of the message, but how people utilize scheduling. Sometimes people schedule things in a matter of fire and forget, right? Well, I need something to happen, let's say 24 hours from now. I'm just going to fire the message and forget about it. And sometimes people abuse messaging services by storing messages and trying to query those as if it was database. So the second scenario is not suitable in general for messaging, I would say, and definitely not for Azure Service Bus, because there's no good way of searching messages that are in queue, right? It's just not database. So if you need that kind of functionality to say, I need to know how many messages are there for, client X, and the client X is information within the body of the message or the header. No, that's not for messaging. All right. So again, a lot of options, right? The more the better. There's more than one way to schedule a message. One way is just to fire and forget. Literally, having schedule message async call, which puts a message on a queue, right? And sets the in queue time or the moment in point in time when the message should appear. Now, it's funny because if you look at the queue, if you pick the messages, and picking is basically looking at the messages without receiving, just receiving without taking the list, you will see that the message is on the queue. It's just not available for receiving. That's it. That's really what it is. The other option to schedule a message with a receipt. So we schedule the message async, but we take what is called SequenceID. Now, what that SequenceID is kind of interesting. Again, this is going back to the broker. On the broker, there is a concept that every queue has a sequence generator. So it's literally a sequential number. And every message that is in queue is assigned a sequence ID. And that sequence ID, it's just a number alone, can be used later to cancel the message if it has not been received already. Right? That's the idea. Now, there's probably a question for some of you, wait a second, Sean, why are we canceling message by sequence ID rather than message ID? Well, two reasons. Message ID is not unique. Sequence ID is unique. Message ID is actually considered to be, even though it's an application property, it's more like a user property, because very often there are scenarios where you want to assign your custom message ID, and it's not guaranteed to be unique, right? If you don't assign anything, it will assign a GUID of some sort. If you do assign your own IDs, it's not guaranteed to be unique. And we'll see another feature based on. The other thing to keep in mind, sequence ID are sequential per entity, per queue, which means that you can have two different queues that giving you the same sequence ID. So you need to be careful. If you're working just with one queue, not a problem. If you're working with multiple queues and you store in sequence ID, you have to know what queue that sequence ID belongs to, right? So the idea here is, for example, you've scheduled something, and let's say doctor's appointment system, and you need to be able to cancel those. Then you require to store that sequence ID somewhere in the database. So that's the use case. So this example, we're going to send two messages, right? The first one and the second one, we could cancel the second because we got the sequence ID. The first one, we had to wait until it's received. Right? We wouldn't be able to cancel it ourselves. So if we can schedule in messages, there's another concept associated with time, which is TTL, or time to leave, right? Expiring messages. There's kind of two ways to expire messages, and I'll explain what I mean. By default, maybe I should not show the code first. By default, there is a TTL, or message expiration time, defined on a queue level. And if you tinker with one of the Service Bus tools, manage the namespace, you will see that by default it's a time span max or something like that, huge number, right? So message can live for multiple years on the queue. The other way is to override the queue TTL and specify it on a message level. Right. So, for example, let's say I'm sending time-sensitive information, and if it's not processed within 30 seconds, the message should just disappear. That's the idea. That's the second way, defining TTL, or time to leave, on the message level. Again, it's a system property. What happens then is when the message gets into the queue, if it's not processed, in our case, within 3 seconds, that message will be purged from the queue. It will disappear. Now, there's one caveat, and I can't state that that's exactly the case, but I think what has been done by the service bus broker team is there was some optimization implemented. Because in order for messages to expire and to be removed from the queue, there has to be an active receiver. And if you think about it, it kind of makes sense because if I keep sending messages that need to expire, but I never receive any of those messages, the unnecessary compute that runs behind the scenes to expire those messages and purge them out of the queue really doesn't have to run, right? Unless there's that very first receiver that connects, and then behind the scenes, all the expired messages can be just brought. So for this demo, what I'm going to do is I'm going to simulate an active receiver to see that message actually is getting expired, right? And is removed from the queue. And the way I'm going to do that is I'm going to use the processor, right? Pay attention to what we're doing here when we receive a message. So I'm sending a message, and I'm going to receive a message, right, in my callback. But when I receive the message, I abandon the message. Okay, remember we talked about the fact that we can settle messages, and settlement is not just a completion. We can also abandon messages. When you abandon a message, basically what you do is you indicate to the broker saying, hey, take the message back. I'm not going to do anything about it, not completing it. Make it available to whoever wants to handle it. Now, it's not going to the back of the queue because right now we're only going to have a single message, which means I will receive it again. And I don't want to continuously receive that message. I want the message to stay in the queue. So what I'm going to do is I'm going to delay my callback by 5 seconds, which is way more than the TTL on the message itself. And because we have this sort of receiver, the queue will say, oh, there's a receiver, and I have an active receiver, and I have an expired message, go ahead and purge it, right? Just to show you how the broker will actually clean the message. So again, going back to Service Bus Explorer, we're going to run our code. The queue doesn't have any messages. We sent the message. Here it is. We're emulating our receiver, and after 3 seconds, bam, it's purged. Okay, that's the idea. All right, so with that, we can go to the next feature, which is called message forwarding, also known as auto forwarding. It's an extremely powerful feature, even though initially it doesn't feel like it. Feels kind of weird. Why would I do it? The topic of topologies that we'll cover a little bit later, we'll see how it comes together. So what is it? It's basically chaining entities together, right? In order to automatically forward messages from one queue to another queue to another queue to another queue. This is just an example of how to set it up, right? You can create the queues. When you create the queues, one of the options is to specify in the queue where to forward the message, right? So in this case, I have Q0 that is forwarding to Q1, Q1 is forwarding to Q2, Q2 is forwarding to Q3, so on, so on, right? There's no Q5 here yet. That's an example. But the idea is that I can now send a message to Q0, and it should appear on Q4. So what we will do in our code, well, I'm going to omit the code, but I'm going to send to Q0, and I'm going to receive from Q4. Successful receival of the message will prove that auto forwarding is working. Right now, you're probably asking me, Sean, like, why do you do this? Why do I need to chain up to 4 queues? That's not a realistic scenario. That's just a demo. But think about this. In production, you have a queue, and that queue is processing messages. You're going through some re-architecture or whatnot, and suddenly you need to utilize a new queue. One of the easiest ways to do is to treat Q0 as your legacy queue, come up with a new queue, and when you're ready, auto forward from Q0 to Q1, which means all the senders to Q0 don't even need to know that there is another queue that other receivers will be consuming, right? Because it will be all the messages sent by legacy system to Q0 will be auto forwarded to Q1. So if we run the code with the setup that we've seen right now, sending to Q0 and receiving from Q5, we got the message, which means that auto forwarding is working. But this is not the simple I wanted to show. What I really wanted to show is like, okay, can I easily do what I told you? Let's say that from 0 to 4, this is all legacy, because every year we need to, rewrite everything. We now have Q5, and I want to receive from Q5. So basically, using this logic, all I need to do is to go to Q4, update it to auto forward to Q5, and we're done, right? So just for kicks, if you think that this is going to work, right, write down it will work. If you don't believe me it will work, write down it will not work. We can't really have a poll, so forget about it. It's just fun stuff. We're going to run this code. We're going to receive from Q5. Right? Let's run it. So we added that forwarding, and we got nothing on Q5. If we go to Service Bus Explorer, look at the queues. Look at that. There's a middle column. And we got our message in that middle column. And there is a dead letter reason, which I'll talk about in a second, which says maximum transfer hop count is exceeded. So the truth is the broker has a hard stop on the number of hops that can take place. And that number is 4, for whatever the reason. What it's doing, it's trying to prevent unnecessary cyclic movement of the message that might be potentially a mistake. And after more than 4 hops, well, after 4 hops exactly, actually, it will dead letter the message. And the dead lettering concept is coming through. What is dead lettering? We're going to talk about this in a second, but basically think of it as tossing a message into a garbage bin. Because what happened is the broker detects too many forwardings and says, something is wrong. I'm going to put this message aside because I don't want to reprocess it and I don't want to get hung up on. Okay? So with that, let's look at forwarding, or sorry, dead lettering, aside from forwarding. And the truth is, remember I told you there's multiple entities. One of the entity type is queue. Every queue has a sub queue, which is called dead letter queue, or $ dead letter queue. So think of it as a nested queue. That's the garbage bin. So any message that is dead lettered, for whatever the reason, dead lettered by our code, dead lettered because we exceeded, more than 4 hops when we try to auto forward messages, dead lettered because message has expired. By the way, we can also dead letter messages on message expiration. So for all those reasons, when the message is dead lettered, it goes to that additional queue. Now, let me give you an example of what I'm talking about. Again, I'm going to create a queue with a few options, configurations. Again, this is server-side configurations. For example, I've had messages on message expiration. By default, it's false. When message is expiring on a queue, it's gone. It's eliminated. If you set dead lettering on message expiration, the message will not be gone. It will be gone from the active messages, and it will go to that sub-queue called dead lettering messages. Another reason why messages are dead lettering, as I mentioned before, is exceeding number of not retries, but message deliveries. So I'm going on purpose set max delivery count on the queue to 1, which means I will only have 1 shot to process a message. If I'm failing to process the message, where will it go? Everyone should shout, dead letter queue. All right, so this is what we're going to do. We're going to set up 3 different messages. We're going to have first message with a time span of 1 second as a TTL. We should never receive this message, right? Because it will be basically never delivered. But it should be dead lettered, and we should find that message in the dead letter queue. The second message, right? I'm just setting a second one and a third one. And what we will do in our processor is the following. We're not going to autocomplete. We're going to complete it messages ourselves on purpose. I do that. And we're going to have max concurrency equal 3 so we can process them out of order, whatever comes first. If we receive a message with the subject first, and I'll go back and remind, the first message is the one that we set TTL of 1 second, which is basically immediately. Very unrealistic, sorry. We should throw an exception saying we should never see the first message. If we receive a subject for the second message, we're going to abandon the message ourselves. Now, if I go back and remind you, we set delivery count, maximum delivery count in the queue to 1. And if we receive the second message and we go here and we abandon the message, we're basically saying, go back to the queue. We are, in effect, going to exceed the number of deliveries that is possible for that queue, which means the broker will automatically take the second message and push it into the dead letter queue because we've exceeded the maximum number of deliveries. Well, we haven't exceeded, but we're about to exceed, right? And the third message, I'll show the third message. There's nothing, abnormal or unusual about it. It's just a message. What we're going to do is we're going to dead letter it manually ourselves. So we're going to force the broker. We're going to say, you know what? Can't handle this message. It's poisonous. It's invalid. Whatever the reason, dead letter the message. And what's interesting is when you dead letter messages, you can also specify your, not just the reason provided by the broker, but your custom dictionary with, it's a key value, basically collection, right? And whenever you dead letter messages, I always tell people dead letter with a reason, right? Because if you decide to dead letter a message, there's got to be a good reason. It could be, cannot deserialize the payload. The message is of an old format and can't handle it, right? Or anything like that. Provide some insights into why the message is dead letter. All right, if we run this, remember first message we should never see, second and third, we received all 3, sent all those, we received 2. If we look at the queue, the second column represents those 3 messages, exactly like we said. First, second, and the third. Don't assume the order, it just happened to be in order. And you will see that the first one is dead letter because TTL expired. The second one, because the max delivery count has exceeded, because we received it once and tried to receive more. The third one is dead lettered with our custom reason, right? Just because we can. So these are multiple ways how messages can end up in a dead letter queue. So that's dead letter. The next feature is a little bit more of an advanced feature, but very simple concept, to be honest, which is PubSub. And this is where we're going to talk about not just queues, but other entities as well. The idea behind PubSub is basically, I don't want to send this message to a specific destination. I want to fan out the message, but I don't know the receivers, right? Very similar to the broadcasting of a traditional radio, right? We want to broadcast a message. We don't know who's going to receive it. Whoever is going to tune into our broadcast will receive that message. Otherwise, they won't. And honestly, broadcaster doesn't really care who is listening or who's receiving those messages. So senders, let's say on the right side, they know about topic. So if we're talking about a dial on FM radio, the topic is the frequency, that specific point that a publisher needs to know about in order to transmit, and subscribers need to know in order to receive, right? Receivers create a subscription, basically dialing to that radio station. And there's another entity type called filters. Those are rules. And I'll explain what that means. In our case with radio, as an analogy, we don't really have rules, but we'll come to it in a second. The rules, if you think about it, it's like okay, I know that I can receive the messages, but can I also filter out those messages? Because a single topic might have, broadcasting multiple things. I guess the rule, the equivalent of a filter, would be a rule what programs I'm listening on a given radio station, right? I'm only listening to the breaking, sorry, not breaking, it's news, right? Everything else I don't care about. So these are the rules. Let's just visualize it. So the first type that we've already seen, again, I represent all of them as queues because topics and subscriptions are also queues behind the scene. We're going to have messages. Let's say we're going to have a message with type order and with type quote. The publisher is always publishing to a topic, to a single point. And the subscribers subscribe to a topic. But when they subscribe to a topic, they also define their rules. If they don't define the rules, they're basically going to receive everything that that topic gets from the publisher. In this case, my first subscriber is going to say, I'm only interested in messages of type order. The second subscriber is specifying a rule saying, I'm interested in all the messages where a type is a quote. When those messages are sent, they're filtered out by these rules. And each subscription gets only the messages that it's interested in. Now, subscription is a queue on its own, as I said, which means that it stores copies of those messages. About rules, filters, and actions. It's one package. A rule has two parts, a filter and an action. A filter is literally filtering out a way to filter out messages. It can be Boolean filter, SQL, or correlation. I'll explain in a second each one of those, what they mean. Action is a way to stamp a message that satisfies the filter or one of the filters. So for example, by default, it could be the filter, the rule name, or we could stamp, for example, and anything that is an order of a message of type order, we want to rush it. Basically, adding custom properties or headers. And since I've mentioned this, filters can only operate on the headers. Headers and system properties, or user properties, or application properties, and system properties. The rules cannot operate on the body, on the payload, because payload is not available during filtering. If you really need to filter on something that is within the body of the message, you have to elevate that value into one of the custom headers, into the application property. So before you send, right? Now, filters, Boolean SQL correlation. Boolean filters, well, it's kind of simple. I want to receive all the messages. So 1 equals 1, right? True, all the messages. SQL filters are the most advanced. This is where you can start saying, I want to have a header called type, and it's a rush, or label is equal to certain value or within certain values, right? Like a collection of values that are acceptable. So there's a limit to the SQL filters, but it's quite powerful. For example, let's say you send messages of a type, .NET type, and you want to filter those. You can have a header, which represents the .NET type, and a SQL filter that basically filters based on the .NET. Correlation filters are extremely effective because they're very performant. It's basically literally a quality filter, but they only operate on the system properties: label, message ID, subject label is the same thing, content type, things like that. There's a list of the properties that you can utilize. Now, if you can, correlation filters are much more performant and better to utilize, but they're not as flexible as SQL filters. SQL filters, on the other hand, allow you complex filtering, but they come at a cost. Now, often the question is, okay, Sean, how big of a cost it is if I have, 10 subscribers with 10 SQL filters? That's nothing. When we get into, hundreds and thousands of subscriptions with hundreds and thousands filters, that's a different topic. One thing that you have to remember is that SQL filters are not lazily evaluated. They don't have short circuiting. So it literally evaluates the whole thing. It doesn't stop if only a part of it is true and normally would be able to stop. Okay. Usually this topic is not covered in terms of performance. You don't have official documentation saying this number of filters and this number of subscriptions is the maximum. Well, you have maximum number, but not performance numbers. So your mileage may vary and you have to benchmark and see what you do. Since I already mentioned this, again, correlation filters are extremely fast. SQL filters, not short circuiting, and you have to keep that in mind. Now, how do we set it up? Again, it's the broker side. We have the options. Every filter has a rule, right? Sorry, every rule has a name and has a filter. A filter is either correlation filter or SQL filter that we use in here with whatever what we want to do. An action is not mandatory, it's optional. Most of the time people don't use actions unless they really need to. So in this case, the first rule or the first filter is correlation filter, seeing any message that has a subject that has a branch, my subscription will get it. The second rule says, first of all, the name, and it has a filter of SQL type, and it says, if I have an application property, which called currency, the key is currency, with the specific value of Great Britain pound, or that currency value is assigned, right, for the currency, then I will get the message. But not only I will get the message, when I get the message as a subscription, I will also set a custom header or application property called status to the following value. So when a message is coming in and it satisfies the filter, the criteria, where the currency is equal to the currency we're looking for, that message on the queue, on the subscription queue, will also have an additional header called status with this value. So you see actually some kind of interesting mechanism to be able to modify headers of a received message on the fly. Now, the way we're going to invocate it, I'm going to create a topic named topic, and it will have two subscriptions. One is called Always in Rush, another one called Currency Subscription. Right? We're going to send two different messages. First messages is going to have the subject set to Rush. The other one will have subject set to Rush and the application property for currency. Right? So we're going to send that and look at the Azure Service Bus topic and the queue subscription to see exactly what's happening. So these are the two queues. One of them has two messages and another one has only one message. Right? It's correlation versus SQL. So they always in Rush receive two messages because, well, we had the rule label equals Rush. That's the correlation filter. Right? The other subscription queue received only one message because only one of those messages had the currency property or header. And if you look at it, in addition to the currency, now we have also the status, which we stamped the message that we received. Also something to remember, what the broker is doing, it's always stamping the message headers with the name of the rule that was evaluated as truthy and caused the message to be received. So if you receive a message in your subscription, in your subscriber, and you're wondering how come the message went through because it shouldn't be, always look at the rule name header to understand what is wrong with the filter on that subscription. Right? That will basically help you to troubleshoot. All right. So that's the pub sub, right? Again, pub sub is literally intended to separate or what's the right term? Sorry, lacking term, to decouple between publishers and subscribers. You don't care who the subscribers are, how many of them, are they online or offline? All you know is you just publish a message to a topic, and the subscribers, when they're ready, they come online, they connect to their subscriptions or whatever the mechanism that they use, and pull those messages or receive those messages. Remember that just like on a normal queue, subscriptions or subscription queues can also have TTL and everything else, which means that if subscriber has not received the message within a certain period of time, we could expire those messages. When the subscriber connects to the subscription, those messages will be published. All right, to the next feature, batching. And very often there's two options for batching, right? There is a batch receive when you need to receive more than a single message, and batch send. Batch sending is more common than we think. Batched receive is a bit more problematic just because the nature of Azure Service Bus, it's a transactional messaging, which means the value of every message is important. So most often processing is done of a single message. But if you need batched processing, you can do that by receiving, up to a certain number of messages. I'm not going to focus on that, more on the sending, because also sending has quite a few edge cases, I should say. So the first type of batch sending is basically having a collection of messages and then passing that collection into send messages async, as in plural, right? And that just sends the messages off to the broker, nothing special. So I'm going to, run that type loop, and looking at the queue, we should have our 10 messages with deep dive from 0 to 1. Great. That's exactly what we need. Now, it sounds very simple and trivial, straightforward, but what happens if we try to send more messages? So in this case, I'm not going to send, 10, 6,500 messages. And obviously, there is a difference. Can you spot the difference between this code and the previous code? And it's not the number of 65,000 messages. We already acknowledged that. We're sending more. What else? The payload. The payload is no longer just a single digit, which means that now we are increasing the total size of the payload. And you have to remember, when we send messages in a batch, we don't send them one after another. We actually collect them together and pass it through as if it was a single message. And it has an interesting side effect. So I'm going to send kickoff, 6,500 messages. Bam, we're exploding with a very interesting one. So this is something I don't like about the new SDK, so that you don't think I'm a fanboy of the new SDK. Every exception thrown by the server is translated on the client side, because remember, AMQP, stateful connection, every exception is translated into local exception, and it's always service bus exception. Always, 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 which is kind of frustrating, because what you need to do is you need to filter your exception, or interrogate the exception for a property called reason, and the reason is the real deal, right? So we're failing because message size exceeded. So individual message could not exceed that size because it was deep dive number, whatever. It's because we're sending it as a batch. Collectively, they exceeded 265K because I'm using standard tier, right? So what's the solution? We can't send multiple messages together and without risking to get an exception. Yes, we can. There's another way. And it's called safe batching. Well, it's not called safe batching. I call it safe batching. So it would be kind of nice if the name will grow legs and spread around the world as safe batching feature. The idea here is that we send a batch using a construct provided by the SDK, where it's building up the batch until the point where it no longer can take new messages, right? So of the sender, we create the message batch with the options, and the only option that is available, what's the maximum size in bytes that we can allow, okay? So for example, for a standard tier, would be 256 for premium 100 megabytes, though then I'm not sure why we would batch those messages. And here's a tight loop. What I'm doing is I'm passing 5 messages. And the way I'm passing it to the batch, I'm trying to add a message. The nice thing about safe batching is that it tries to add, it calculates actually the size of what that message will translate into and how it will impact the total size of the batch. And it will return Boolean true or false wherever we can or cannot include the message in the batch. So this way, what you can do is you can chunk up your messages into several batches if necessary and ensure that they are sent, right? And the batch can report the total size and that it has accumulated over the time on every iteration of the loop. Okay, if we run the code, one thing before I run the code, I just want to highlight the fact that message batch creation is done on the sender object as opposed to just newing up a batch. And the reason for that is because the batch needs to be aware of the link that exists with the broker in order to determine things such as the maximum size batch, which is set by default, right? Things like that. All right, so if we send those messages, 5 messages, this is what we get, right? We get batch building up from first message, see 39 bytes. So even though it was just deep dive number 0, it's already 39 bytes and 73, 107, 141, and then the last message did not get in. For the sake of the demo, I don't care, but if it was a real world scenario, I would just basically send the batch and reset the batch and start it from the beginning, right? And these are the messages that we have received, 4 messages. The other thing that you might ask is, okay, Sean, but do I necessarily need to batch them? Like physically sending messages as one chunk? Can I just do send at a time? Batch sends? Yes, and we'll talk about it in a second. What happens if I work with the standard tier? I cannot utilize the premium tier and the message is larger than 256K. Well, in this case, batching won't help. You either need to upgrade to premium tier or, well, in the past, you could use like attachment plugin or compression plugin, which would reduce, the first one would basically use the claim check pattern. The second one would zip up or compress your payload. This is not an option, but we do have a way to define our own extension points, similar to what plugins used to be, and we'll see that in a bit. So that's with the batch sending as a single payload. What happens if we want them as separate payloads? Well, this is where atomic sends are coming in. And unlike batch, we don't have a group of messages that we can just send out. It's usually happening at intervals of time. So I'm running some logic, I have a message I need to send, and running a bit more logic I need to publish, and running a bit more logic, last message I'm sending. So I can't, or I don't want necessarily to accumulate all the messages and send them as batch. So how do we do that? Well, if we do individual sends, we can wrap those sends in the transaction scope, allowing async flow operations, right? Because we're using IO bound operations. And what happens is I can send my first message, I can send my second message. Nothing is going to show up. If there are receivers on the other side, they will not get those messages until we indicate to the broker that we are done. And the way we indicate to the broker by completing this transaction scope. And what will happen is literally we're going to run, we're going to send those messages, 1, 2, and they will be received, right? Two messages on the queue. There is one thing, though, that I want to warn about when you're doing this. People that traditionally coming from a very transactional world background where, on-premises, DTC, everything is spanned by a transaction and participates in that ambient transaction, that's not the case. If I would have a database operation in between these two sends, that operation would not participate in the transaction of the service bus. It would not. Azure services do not support DTC, right? So it's the transaction scope is only possible on the service bus operations. That's it. And it's important because we're going to look at something in a few seconds, and it will explain what I mean. Now, there is a hard limit of 100 messages, literally. By definition, the broker will not accept a transactional send, or atomic send, I should say, of more than 100 messages. If we try to, none of those messages will be sent. So if we send 101 message, you will see that we will receive an exception, right? Quote exceeded exception, that will be the reason. And it will literally say that a single transaction can only support 100 messages. It will also give you this reference with a GUID and tracking ID. If you open in Azure support case, this tracking ID is extremely important because that's basically a lookup ID for what has happened exactly, allowing Service Bus team to pinpoint the time and the operations that we're executing when this exception took place. But that's just a second. Now, can we do atomic send with a batch? Absolutely. But just remember that the exactly same rules are applying, batch or no batch. If we're trying within transaction scope, sending more than 100 messages, we're going to get an error, right? That's just a hard rule. And as you can see, quota exceeded. Now there's another interesting feature called cross-entity transaction. In the past, it was also documented as send via. And this is a bit more advanced than just atomic or atomic operation. This is where we want the incoming message and the outgoing message or messages to participate in a true transaction. In other words, everything succeeds or everything fails together. The way it works, just to visualize it, is that we have normally an incoming queue, right? Let's say our processor here receives a message. When it receives the message, it basically sends another message or publishes an event to some arbitrary queue, some other queue. And at the same time, we're still processing our message. We want to send to another queue B, but what's going to happen? The message is not going to reach its destination. It's going to sit on another queue under the original queue. So remember, every queue has a dead letter queue. And now I'm introducing additional sub queue called transfer queue or transactional transfer queue. That queue on the broker is literally used to store the outgoing messages that will participate in a transaction. So if my processor also needs to publish to or send a message to another queue B, it will not be sent to the B as part of the transaction. It will be stored on the incoming sub-queue transfer queue. I know it's a bit confusing. And I can have a third destination, same story. My code is sending a message to C, but in reality, it will be stored on the transfer queue of the incoming queue, that sub-queue. When the transaction is completed, what you will see, and this was too quick, I'll repeat it again. What you will see is that the incoming message will disappear and all the outgoing messages will appear on the destination queues. And that's why it's called cross-entity transaction or transactional send and receive, right? And as far as I know, this is quite unique to Azure Service Bus as a broker. Azure Storage Queues doesn't support that. RabbitMQ doesn't support that, and this what makes Service Bus extremely powerful for enterprise applications where, for example, you're processing orders or each message is important and you want to have the transactional boundary between incoming and outgoing messages. It eliminates things such as ghost messages, scenarios where you need to retry the incoming message, but the outgoing message is already left. Or where you failed to send one of the outgoing messages and you can reprocess the incoming because it has been completed. That is eliminated. So how do we set it up? Well, I'm going to have some sender to send a message to the input queue, but the receiving is going to be slightly different, because with the receiving, and I'll go into that in a second, with the receiving, when we create our service bus client, which is missing from my slide, I actually have to, in the options for service bus client, I have to say cross-entity transaction or enable cross-entity transactions, right? To basically indicate that I want that feature to be used by the client. We wrap it in a transaction scope. Our operations, this is the processor. We received our message. As a result of my operation, I'm going to send, in this case, only to one queue, to the destination queue to make it simpler. I'm going to complete the message, right? Still, the incoming message is not going to be completed at this point. The destination will not have its message at that point. Only when we're going to complete the transaction, suddenly we'll see that the destination has the message was sent to it. The incoming queue will not have its message, and I'll show you. Let's run it. So a single message for incoming, single destination. And I'm going to print out state of the queues. So let's see what happened. We received message from a queue. One message was in the queue because we received it in peak lock mode. That technically we're releasing the message, right? It's not gone from the queue. We entered our transaction scope, sent a message to destination. Notice no change in the queues. Incoming message is still there. Outgoing message is not in the destination queue. We completed our incoming message. Still, it's on the incoming queue. No messages in the destination queue. And when scope was completed, bang, the incoming message is gone and the destination has the message. So that's the transactional message processing. Now, things can go wrong. And when things go wrong, they go bad. Let's take this example. We're going to have our transactional processing. And just before we complete the transaction, I'm going to throw an exception. Now, it would be really fun if we would have the poll asking people, what do you think is going to happen? Is it going to work? Not going to work? Right? How is it going to work? And here's the trick. It will work. It will not work the way you expect it. Because one of the things that Azure Service Bus is really good is about its guarantees for transactional processing. So in this scenario, obviously transaction cannot be completed and there is something that can go wrong. In this case, it's not that bad, but things can go really, really wrong and messages should not be lost. And the way Azure Service Bus achieves that is by having transactional dead letter queue, sub-queue. So this is another sub-queue for every queue that exists out there. It's called transactional dead letter. Let's see how it works. So in this sample, I'm going to output the input queue, the destination queue, and the transactional dead letter queue. Right? So we're going to send that message. And let's see what happened. We received the message just as before. We sent message to the destination just as before. We completed our incoming message, same as before. But then we had the exception, right, that something went wrong. Where's that wrong? In the transfer dead letter queue. Now, remember, every queue has a few sub-queues, and the transfer dead letter queue is the one that we're going to monitor. So, same code, except what I'm going to do, instead of just throwing an exception, I'm going to emulate a situation where the broker is getting into the mode that is exceptional mode, and the transaction cannot be completed, in basically mimicking some sort of failure on the broker side. And the way I'm going to do that is I'm going to disable the destination queue, right? Disabling, you can disable queues for receives or sends or whatever the operations. We're going to disable the queue by doing that in the middle of the transaction, we're going to emulate the situation, the disaster situation. And the way we can disable that is basically by literally running update on the queue, on the entity, and saying that its status is disabled, sent disabled, cannot send to the queue. Let's run the same thing as we saw just before, a second before, with the transfer dead letter sub queue. So we're going to send the message, complete the incoming, and then we're going to run into a problem. See, notice we completed the incoming message. We have still one message in the queue, 0 in the dead letter queue, 0 in the transfer dead letter queue, 0 in the destination. And then we emulated that disaster, and the scope completed. The incoming message is gone. Destination did not get its message because we didn't finish processing the incoming. There's nothing in dead letter queue because, well, it's not dead letter queue scenario, but transfer dead letter queue message has the original incoming message. What it gives us an ability to resurrect the message that has incoming message that has failed the transaction and reprocess it again. So why this scenario is so important and so many systems completely ignore transfer dead letter queue, which is a mistake, because this can create an illusion of transaction completed successfully and yet nothing happened. We handled the incoming message successfully. We didn't have any output. We didn't actually emit a message outside. And what just happened? Right? So that's why monitor queues in production. Monitoring dead letter queues is not enough. You also want to monitor transfer dead letter queues. So this is the edge case where service bus property says, I cannot successfully complete this transaction, even though on the client side, the indication that it was successfully complete. But what I can guarantee is I'm going to hold on to the incoming message to allow you reprocessing later. So I don't know how many people will go tomorrow and check their production systems for the transfer dead letter queue, but I'm sure it's going to be an interesting exercise. Another thing to mention, remember dead letter reason, it also stamped on the transfer dead letter messages. And the reason why this is important is because you need to understand what caused this abnormal behavior, right? So the reason is there. Yep, a little bit mind-blowing, but that was my pretty much reaction to this sub-queue when I discovered it. All right, topologies. We talked a little bit about topologies without necessarily mentioning the name. Remember when I showed you the auto forwarding, when you can forward from one entity to another, from one queue to another queue? Because entities are queues and subscriptions, everything is queue. You can actually start forwarding from queues to topics, or from subscriptions to queues, from one topic to another topic. You can create those topologies. And topologies are not just to, being able to receive from a new queue without making modifications to the existing system. Sometimes it's really nice to organize how you process, how you receive messages and process them. So the way in which parts are interrelated or arranged, which was said, that's a topology. So this is a very simple topology. Auto forwarding from Q1 to Q2 is a topology, right? So Q1 is legacy, the new system is using Q2. Now I need to receive messages from legacy in the new system. Auto forwarding, that's my simple topology. There's a bit more advanced topology. For example, I have different subscriptions that my process can create. My process has a queue. And by having subscriptions, now I have to also listen to the subscriptions and pull messages from queues and subscriptions. Very inconvenient. What I can do is I can set up auto forwarding from the subscriptions to the input queue. So there are several benefits for creating a topology such as this. For example, rather than creating 3 different connections to my namespace, Now I need to have only one connection, right? Because I'm only listening to the messages on the queue. Any events or messages published to a topic that my subscriptions are going to receive are going to be auto-forwarded to the queue and essentially delivered to my process, right? Now, if I'm going and scaling the processing of this queue, scaling out, I'm increasing number of connections because each scaled out instance is a connection to the broker, but I'm not going to do it 3 times because it's only one connection that I need to establish. That's one thing. Another benefit of creating topologies such as this one is, for example, I want to scale out and in based on queue length or queue depth. It's kind of hard to do it if you're listening to multiple queues or subscriptions, right? What I want to do is I want to have a metric on a single queue, which will basically decide wherever scale out or scale in. And by having this topology, all I need to do is watch the input queue and based on number of messages, scale out and scale in. Again, it's not necessarily something you have to do. It's just an option, what you can do on the server side in terms of arranging your entities, your queues and subscriptions and topics to basically build a solution that is matching your world. I'm going to skip this one probably because we don't really need to go into details. Next, amazing feature, and again, quite unique to Azure Service Bus, is message sessions, also known as FIFO queues or first in, first out. And you're probably going to say, Sean, this is not unique. You can do that, for example, with AWS SQS. You can set queues as FIFO queues, and you're going to get the same. Yes and no. And let's have a look at how it works. So let's say I'm having messages color-coded, and each color represents a session. So for example, when you go to grocery store, like me, because you refuse to buy everything online, you go to a tilt, you're scanning your produce, and you really want only to pay for the things that you're paying for. So it's a session per customer, for example, right? Also, very often, you want to be able to preserve the order. So if you scan first item, bananas as your first item and watermelon as a second, you want to see it on the printed receipt. First the bananas, then the watermelon, because you know what? The OCD, I want to see the items in the order they were scanned. Sessions allow exactly that. When instead of just sending and receiving messages, I will work with session sender and session receiver, if you wish, right? So for sending, it is basically indicating what session the message belongs to. For receiving, it means I'm receiving from a given session. Now, you don't have to lock yourself into a session. You can basically pick sessions randomly, and we'll see how it goes, how it works. So this is the scenario we're going to use, right? We're going to send a bunch of messages randomly based on the color-coded sessions that we have. To translate that into the code, the queue or the entity created on the broker has to know that it's session. Okay, you cannot mix. If the queue is defined as session, it has to be session. If it's not, then you just don't use the property, right? Because the receiving from this queue is different from receiving a normal queue. The way we will send messages is basically creating the messages, and the system property that we're going to have, session ID, will be assigned a color code. A session ID could be any value that you want, right? It's just identified. Receiving is slightly different. For example, to use a processor, there is a session processor. It's almost the same concept, except it's not, slightly different. For example, obviously the names are different. In this case, I'm going to set max concurrent sessions is 1. What that means is, remember concurrency, scaling out? I don't want to handle more than a single session at a time. Why this is important? Our human brains, right, lizard brains, we want to prove that we can use FIFO. In order to prove that we can use these queues as FIFO queues, we have to have the order of the messages received in the same order as sent. So if we're gonna start if we'll start concurrently sessions, we'll see green session, orange session, go prove that it's working. So now what we're doing is we're literally going to see messages received, random sessions, we don't care which one's first, last, but within the session, messages in the same order as they were sent. Now, session idle timeout means, hey, if you don't have any messages anymore for that given session for the given session that you were just handling, switch to the next session, right? That's to ensure that we're handling other sessions as well. Now, the other setting, max concurrent pulses per session, that's an interesting one. Within the session, so we care about splitting the sessions. But if within the session you don't care about order of the messages, right? Then scale it out. We're going to create our processor, right? The processor, the callbacks are very similar to what we've seen with regular processor, which is going to output the message ID with its color or the session ID, right, and the body. And if there's an exception, we're going to output the exception. All right, let's run this. The order that we sent, look at this. We get first session happened to be orange, and we get orange 1, 2, 3, 4. Then we started handling greens. 1, 2, 3, 4, because that's the order we sent them in. Then we handled the blue. 1, 2, 3, 4. And purple had only 1. So this way, we can handle guaranteed ordered messages with a queue structure that resembles to FIFO. Now, if you don't care about the order, that's fine. That means that you can, within a given session, you can do many messages at the same time. They will be just out of order. That means on my receipt printed out, the order of the produce is not going to be the same as scan. But the nice feature, whatever you care for that or not, is that you can also handle multiple sessions at the same time. You don't have to handle only one session. In other words, if you have multiple tilts at the grocery store, you can handle them concurrently. Another aspect of sessions that is important, every session has its own state. It's a basically binary object that can hold arbitrary data as big as the size of a single message based on whatever tier you are, right? That session remains as long as it's not clear, as long as we have messages. And if all messages for that session are cleared, that object is purged. So it's kind of interesting thing, because think about it, if you have, it's almost like a stateful processing of the messages. You can associate some state that is going to live on the broker with the session. Okay. So that's the sessions or message sessions. Next one is a feature that is related to the message IDs. Remember, I told you message ID is not unique for a reason, because it can be assigned by client code. One of the features that Service Bus supports, the broker supports, is message deduplication. The idea of message deduplication, if I see two identical messages, the first one gets handled, the second one is dropped. But the way the broker, Service Bus broker, is performing message deduplication is not something that is trivial. Most people would think that it's deduplicating based on the body, when the reality is deduplication is based on ID. And the reason for that is because evaluating message body is very expensive if you think about it. That's one thing. The second thing is Azure Service Bus as a service guarantees that it never looks at the payload, never ever. So to deduplicate on the message body implies looking at the payload, right? Reading it, doing something with it. That's why message ID. So the question is, okay, but how do I deduplicate the payload? Well, the answer is simple, because you can set message ID. You can derive message ID as some sort of hash on the payload and stamp with message ID. Sorry, and stamp message ID with that hash, right? And that way deduplication works. So I'm going to be doing something similar. Again, broker needs to know how to perform deduplication because out of the box, deduplication is not turned on. So we need to require deduplication detection to be turned on when creating the queue or updating the queue. And the other thing is we need to specify deduplication history time window, right? Which is basically the period of time that the broker has seen identical message ID and going to drop any duplicates. Okay. And it's the way it works is basically it keeps a record of the message IDs that it has handled, right? There is a data store database behind the scenes. And basically within that period of time, it says, have I seen this ID? Yes, no. If yes, drop the message. So what I'm going to do, very primitive way of basically having the content, taking first 16 bytes of that content and turning that into a grid, right? And sending the same message 3 times. Now, don't be fooled by me. It's not the fact that I'm sending the same message. It's the fact that I'm sending 3 messages with the same ID that matters, right? And when we're going to send messages and we'll start receiving those, obviously we're going to receive only 1 message because the other 2 will be deduplicated, right? So we're going to wait for a few seconds, but the only message we're going to get is the first one. That's the idea. Next topic.
Go on, sorry, is it only the message ID that does that, or can you do it on metadata as well?
Only message ID.
Only message ID, okay.
Right. So, but that's a very good question, actually, Matt, because what you're saying is that, hey, I know how to deduplicate messages not based on the payload ID, but on some metadata. So what you would need to do is you would need to propagate that metadata into the message ID segment. Right? So that's why message ID, as I say, message ID is not unique. It's never unique. It's customizable. And the reason not because you can deduplicate, because your system of origin can emit more than 1 message with the same ID, right? That's the trick. The next feature is a bit unique, I would say, to actually .NET Client, because there's no concept of plugins from the server side. The server side doesn't care about extensibility. It's not posting new plugins. Well, I should say never, but it's not wise to post extensibility on the server side, by the service provider. The extensibility should always come on the client. And remember when we were talking about message size and the fact that the message can be larger than 256 bytes on standard tier. One of the things that you could do is you could think of the sending and receiving as sending and receiving pipelines. If there are any BStock survivors, that's about the moment that you should jump. That's exactly it, right? So the message, when you send a message, it's really going through a sort of pipeline, right? It goes from your code through SDK and whatnot. So, and the receiving is the same thing. Go from the server, there is a MQP link, the lower level of receiving the message, and then the SDK passes it to you as a received message. The SDK team has added a capability of adding your own extensibility as plugins. They not quite plugins, in my opinion, because there's a lot of craft that has to be created, but it definitely allows you this kind of customization. And I want to go quickly through it. So, sender, service bus sender, and receiver can be extended. So, and this is in the official documentation. What you can do is create your own type where you can expect a collection of callbacks, right? Functions that receive service bus message and returns a task, just in case if you are asynchronous. And these are your plugins, if you will, right? Customizations chained together. And what you can do is you can run through those customizations before you hand off to the base implementation, to the SDK sender, the message itself. So in a way, what you're doing is creating that outgoing pipeline where you execute customizations on the message that is about to be sent, right, until it actually sent out. And what you can do is you can create your own extension point, extension method that basically says create sender, but instead of creating the SDK sender, it creates this decorated sender and passing along the collection of your own plugins. Now, in this case, I've created a single pluggable service bus sender, right? Now, I'm also going to create plugins or customizations. It's nothing but a func. In this case, I'm going to receive a message, the message that is about to be sent out, and I'm going to modify the body. Instead of having a body what it was, I'm going to prefix it, insert a new line, and then take the original message body. Obviously, it implies I know that I'm working on payload of the message that is a string. Otherwise, it would not work, and you need to be careful. But usually, you know your system and you know exactly what payloads are. And this interesting binary data, I'm going to refer to that in a bit, right? And that's it. That's all my plugin. That's my sending out extensibility. And the way we're going to use it is we're going to create service bus client, our extension method, right? We'll create a sender. The only difference is instead of just sending where we're sending, the destination, we're also going to supply a collection, that list of plugins, where prefix plugin is this fallback, nothing else, right? Fun. We're going to send a message, deep dive. When it will go out, it will go through this plugin. We'll get this prefix, right? And then we will receive a message and confirm that our adjustment or modification of the outgoing message payload has been successful. Right? So we're going to run this. And I also had an incoming pipeline that modified and added a suffix, right? It's exactly the same idea, but going in the opposite direction. So first, the SDK receives the message, and then it passes that received message through my customizations. So if you look at this is a very trivial example, but basically we have a control over the message before it's sent out. And we have a control over the message at the point when it's received before it's handed to our client code. Which means that we can construct anything that we want. We can create a compression plugin. We can create a claim check pattern, right? Offload the message payloads to storage or something else. We can enrich our messages. That applies not just to the payload, but also the properties, the headers, or sorry, metadata, right? We can do a lot of things kind of interesting that are unique and specific to the solution that you're building. And that's quite powerful. Now, I did show the binary data, and I want to refer to that because traditionally payload is like, okay, I'm going to give you a string, and string is passed around, or I'm going to give you a byte array, and byte array is passed around. And in most of my examples, I think all of my examples in this talk, everything was always a string. It doesn't have to be. A binary data is a type. I believe it's not even Azure Service Bus package specific. It's just Azure namespace that can take any type and simplify the work for us, because typically what do? We have objects, some POCO records, and we serialize those as JSON most of the time. We ship it over with a message, and when we receive, we deserialize it. And the Azure Service Bus SDK can make it a little bit simpler because technically it's using binary data for the payload, and binary data can receive anything. So for example, in this case, I'm taking a string, right? And it's a string. I can also pass in an object, right? Record in this case. And it will be serialized. As you can see, if I take the data and turn it to a string, it will be the serialized object. I can also do something else. I can say data to object from JSON. So when I receive a message, I can deserialize it into the type, skipping serialization part, which usually you do manually every single time, just because it's a necessary craft, right? You always receive a message, you always deserialize it, you always create an extension that basically calls JSON deserialized or whatever, right, to the type. So it's just coming out of the box at this point. And because my object happened to be a record, we get this nice output from the toString. Now, taking Azure Service Bus, these are definitely not all the features of Azure Service Bus. Like I said, I can fill out the room like a gas as much as space there is, but to be aware of the time. There are more features, there are more scenarios, combination of the features together. Not going to list all of them. And as we go, as we speak, there are features that are being added to the broker, even though for a long time we haven't seen these. And I'm not referring to the premium, like large messages support or safe batching. For example, purging is one of the things that you cannot do today. You cannot purge a queue. And if you think about it, it makes sense because purging queue is very dangerous. If you can purge queue in a low environment, you can purge it in production. But what if we would be able to purge a dead letter queue, right? Dead letter messages, quite often you either retry them or you purge them because you're not going to do anything. So that feature is actually under review right now. There are other features, very interesting ones that are coming down the pipe that we'll see. The one aspect of Azure Service Bus I wanted to touch in this presentation is how do we use it outside of the traditional environment where we have a message pump and a tight loop, if you wish, that receives those messages. And serverless is one of those scenarios. It's actually quite interesting. The reason for that is because with serverless, we're no longer concerned about receiving messages ourselves because we're given the messages when they're available. It doesn't mean that the message pump doesn't exist. On the contrary, it exists, right? The messages are still pulled by functions underlying infrastructure. It's just abstracted from us. And if you notice, if you go to Azure Service Bus functions and you start tweaking the triggers specifically for Azure Service Bus trigger, there are configuration settings such as concurrency, maximum number of messages, concurrent sessions. So that knowledge is not discarded. It's still there. You have to understand how it works. With Azure Functions, there's two types, right? There's in-proc SDK and isolated worker SDK. The packages that I'm referring to will help you to filter them out. And the way you work usually is you get Service Bus received message. Notice I don't remember if I mentioned this before, but Service Bus message is an outgoing message. Service Bus received message as an incoming message. And the difference between the two is that received message cannot be mutated, right? It's immutable. You can use it to construct a new message, that's fine, but you cannot modify the incoming message. And similar to what you've seen in the message processor, you can either let functions handle message completion automatically, or you can do it yourself. You can settle messages in any way you want. You can dead letter, you can defer, right, etc. The newer SDK, the isolated worker, the story is slightly different. And the reason why the story is slightly different is because you cannot use SDK types. So for example, in this case, for the in-proc SDK, you notice we receive Service Bus received message. That's the Azure Service Bus SDK type. And I'm referring to the message ID as a system property. With the isolated worker SDK, you actually have to deconstruct the message into the body or payload and the system properties. You cannot get hold of the Service Bus received message because those types are not available. Also, you cannot settle messages yourself. That's quite a constraint these days. So if you have Service Bus triggered functions and you're considering to upgrade to the new SDK, be aware of that. It's, again, because it's out of the process, the new SDK is out of the process, there is a technical constraint. And it's going to be quite interesting considering that we're nearing .NET 7, and after .NET 8, the two SDKs will converge into one to see how the team is going to solve this challenge, right? But just be aware that even though there's two SDKs for functions and both work with Service Bus Trigger, not the same capabilities on both. Outside of the broker, whenever you need to manage things, obviously you can go through the portal. My personal choice is Azure CLI tool, extremely helpful, easy service bus, and you can do whatever you want. So another option, not just management library or your SDK. You can use the Azure CLI to build up your topology, provision all the queues, all the entities, whatever you want. In terms of performance, and that's very important to understand, not just why premium is better, but what's causing premium to be better. And it's a very simple truth. It's the way standard namespaces are deployed. Traditionally, there's a compute unit, happen to be called container as well, but it's not containers that we think, not Docker containers. And that container unit can contain multiple namespaces. Each namespace, right, is comprised of those containers. So for namespace A that I've provisioned for my queues, I have container A1, which has QA and QB. And there's another namespace that someone else is using that has its own container with its own queues. The problem is that compute unit is not a single unit. There are multiple compute units. And if I go and add to my namespace a third queue called QC under my namespace, it is not guaranteed to be on the same container as the rest of the queues were provisioned. Right? It's literally sitting in a different container. And what happens, at least in the past, we see the difference that one queue was really performing poorly when the other queue on the same namespace was performing all right. And it was mind-blowing because you would say, wait a second, it's my namespace, same namespace, two different queues, completely different performance. What's going on? Well, that was the case with when a neighboring namespace within the same compute unit was performing too many operations, also known as noisy neighbor, and was causing throttling on the whole compute unit. So I was punished, even though I was receiving one message a second, for someone who was receiving 1,000 messages per second. Now, gladly, this was identified as service bus busy reason, right? And the recommendation was always, hey, step back, chill off, 10 seconds, and you'll be good. But that's not ideal because that noisy neighbor is causing collective punishment for something that should not be punishing. Nowadays, it's different because whenever there's a noisy neighbor, not everyone is punished. There is a credit system in place for every namespace, and every namespace gets an arbitrary 1,000 credits. Based on the operations performed on the namespace, those credits are reduced and replenished after 10 seconds. Right? So you still might get an exception with an error of server busy, indication that you need to cool off a little bit and retry again. But that is going to be mostly because of your operation, you exceeding the credits, not the neighbor. So, like we said, this neighbor B and namespace B can do whatever they want. I should not be affected. Their credits go down. My operation should continue because they will be throttled, not me. So then the question is, okay, we understand all of this and credits, and maybe it's, with SPICE, with 256K is enough, etc. How do we choose? How do we compare? Well, premium is up to 100 megabyte message size. It's a dedicated resource, right? It's literally provisioned for you. Only your namespace is there, and a single namespace. You cannot have multiple namespaces on premium tier. It is predictable throughput, which is very important. One of the things for this predictable throughput is you also have scale up and scale down in message units. And literally we go from 1 to 16, I think 1, 2, 4, 8, 16, something like that, right? So Similar to SQL Server, when you need more power, more horsepower, you literally can go up. And you can reduce those messaging units as well. Because, well, multiply $670 times the messaging units, it's not cheap. The other benefit of premium is GeoDR, or disaster recovery. But you have to be careful today, because today GeoDR applies only metaplane, meaning all of the queues, the topology, will be recreated in a failover namespace, not the messages, not the data plane. So you're probably asking me, Sean, what kind of DR is that? Well, the DR is the kind of DR we have today. But the good news is that Service Bus team is looking also at enabling data plane DR as well. So there will be failover. Obviously, you will not have 100% of all of your messages, but at least it's not going to be gone. The other thing to remember about GeoDR, it's not passive active or active passive. If you failed over, the original namespace is a burner. It's gone. You cannot resurrect. You can only delete it. So that is very important to remember. That is why GeoDR as a feature on Azure Service Bus is not automatically enabled. It always requires an API call, right? Or toggling it on the port. But again, manual approval, manual intervention. The other benefit of the premium tier is Azure availability zones, right? That's basically pretty much every service today is pushing for availability zones as opposed to running in a single zone. VNet support is crucial for the customers that want to ensure that no traffic is going over the public internet. And communication between the services is done within the virtual network. So only Premium can do that. Standard cannot, at least not today, and a few other things. But on the other hand, Standard tier is much, much lower budget requirement, right? Like $10 flat fee, unlimited number of namespaces, do whatever you want. Multiple namespaces, right? Like literally, if I have a team of 100 developers or I have multiple lower environments, they all can use those namespaces. A fairly decent message size, 256K. Obviously, not a good solution for those that have to deal with large messages that contain attachments that have to stay with the message as a unit. But again, you can use plugins, right? You can do that. And plugins can be configured, for example, in production environment, not to utilize, not to be employed, but in low environment to use those plugins. The other thing that I will mention, I didn't put it on the list of premium, is one of the drawbacks of the plain chat pattern is that you have to manage those attachments and you never know when to clean it up. And the reason why I'm saying you never know when to clean it up is because if you send in a message to a single destination, great, you know when the message is received and you can clean up the attachment. What happens if you publish a message? If it's an event, you don't know who the subscribers are, and you definitely don't know when they're done processing those messages, but all those messages have reference to the same attachment. When you're using premium tier and you're using large messages, that attachment is there behind the scenes on the server side, but you don't have to manage it. You don't have to provide storage account. You don't need to know when all the subscribers have handled their copies of the messages. It's just automatically works. And that's quite nice. But going back to justification of when to use standard, it gets the job done. I mean, not every solution needs premium. So the reality is that right now there's a huge gap between the two, and I do anticipate in the future to see something in the middle, right? Something like pay to play, where you would toggle certain features to pay extra, but not as much as for full-blown premium. That's the idea. So whenever you decide between premium and standard, just, consider the fact that you can use both of them at the same time, based on environment requirements, whatever it is. Now, tooling, it's still a pain point. 2022, and it's still a pain point. There are several options. We do have options. I didn't promise the options would be good. there's a portal. If you ask me, I'm not a big fan of portal tool. There is an ability to look at the entities, list of the entities. When you drill in, you literally can perform some simple operations with the Service Bus Explorer. I call it Portal Service Bus Explorer to distinguish it from the desktop application, open source one. And there is a little bit of work happening to make it better, to improve it, but it's not as robust as a client-side desktop application at this point, right? You can send messages, you can pick messages, dead letter, modify entities, the basic stuff. But again, not the whole thing. The other tool is Serverless 360. It's a really good tool for companies that do a lot with Service Bus and not only. Very powerful. It's a paid tool. Quite nice. So give it a try if you want. And I think 99% of all the Service Bus users is using the third option, which is the open source Service Bus Explorer, created by Paulo and supported by community. Contributions are welcome, so feel free if you want to improve something in the tool. The bottom line is Azure Service Bus as a service is quite powerful. I mean, this presentation should give you a taste of what it is. It's true enterprise messaging with all the features, something like transactional processing with very strong guarantees. The reliability, even when things go really, really wrong, like we saw, you don't lose what's important. Guaranteed throughput, the latency with premium and other features of the premium, all of that is making this service quite unique among all the other messaging services, be it native to Azure or brought from the outside and hosted in Azure. So with that, I'm wrapping up this presentation, the slides, and the code, by the way, all the samples will be available in the repository, so you can download .NET 6, whatever you want to run it with, and you can play set debugger breakpoints in order to understand how it's actually working new to Azure Service Bus. And I blog, sometimes more, sometimes less. I'm on Twitter. My personal opinions don't represent anyone. So if you want to stay in touch, either through Twitter, blogs, email, everything is welcome. And if you have any questions, I'll be happy to answer those.
I think Ian did put one in the chat, basically asking about resilience and what do you do if the Azure Service Bus isn't up all the time, if it goes down, with, I think, like retrying sends, I think, only scanned it. And thinking about resilience, thinking about resilience, we deal with failures in the message handlers, idempotency, retries, etc. However, I'd be interested in what best practice it is when exceptions occur during sending of messages. Like any Azure Service Bus, it isn't guaranteed to be 100% of the time up. How do you handle exceptions when sending a message? I just read it out because obviously for the YouTube recording.
Yeah, I think there's actually a couple of questions within a single question. And I'll start addressing it from sending because it sounds like the primary focus. It is correct. No service is guaranteed to be, 100% uptime. Though I have to mention that foundational services, I think, or Ring Zero, whatever it's called, Azure Service Bus is one of those, which means it's guaranteed to be, and the uptime is quite high. But things happen, and it doesn't have to be Azure Service Bus that is going down, the broker. It could be just connectivity issue because it's a remote service, right? So the thing is very simple. When we send messages or dispatch messages, the message that has not been sent or handed over to the broker will throw an exception. So if there is no exception, it's guaranteed that the message is received by the server. And it's not gone, it's not going to disappear. If an exception is thrown and there is no other state, right? It's either success or exception. If exception is thrown, the expectation is to have the client to retry until the message is enqueued successfully or sent successfully. But the second part of the question, I think, and this is what Ian is asking, what do I do when I get exceptions? And it has nothing to do with Azure Service Bus availability. Like someone unplugged my machine, for example, right? The server or something happened. This is where we, I think, need to face the reality and either design the applications in such way or create for now custom solutions. For example, let's say we are taking orders. When we take an order, we receive the request and we want to enqueue that request, right? We want to transform HTTP request into a message. If I fail to enqueue the message, in my opinion, the best way to handle the failure is to propagate it to the client, obviously not as an exception service bus is not available, because they will go, what? Rather tell them, hey, we're experiencing a technical problem, please retry later. That's one option. Another option is to pretend to be 100% failure safe by storing the request and trying it later. Basically, store and forward. This is what MSMQ used to be, right? If anyone remembers MSMQ. MSMQ, when it was sending a message, it was storing the message physically as a file on a local machine, and only when a remote machine was available, it was forwarding that message. And yes, I would be absolutely thrilled if there was a built-in feature for the SDKs to store the message locally if the broker is not available, and only dispatch when it's available. And if I remember correctly, Clemens Pastors, he's the architect behind Azure Service Bus, he actually had a sample which was leveraging sort of stage sender, where the messages, if the broker is not available, messages were stored as MSMQ messages locally, and when connection was restored, were sent out. So TLDR answer, if you have no exceptions when sending, you're guaranteed the message went out. If there's an exception, it's up to you to retry. Now you could, be fancy and build around something. For example, a plugin for the outgoing pipeline, right? Which basically tries, if it fails, that means the SDK retries have been exhausted, and push that message into, or payload, I should say, into the database. But then my question is, what are the odds if Azure Service Bus is down, that the database is also going to be down, right? Quite high, especially in cloud environment. That is why I'm a big fan of basically going to the client and say, you know what, I can't, sorry, please retry. And nowadays, there's also quite interesting solutions where you can store the request on the client side, actually, right? And keep retrying from the client side as well. So there's a variety of options. Hopefully, I've answered the question.